Alright, this unit is, or this lesson is on moles, and it is probably not on the same type of moles that you were thinking of, but a mole is actually a way to express an amount of something, kind of like saying a dozen. A dozen means you have 12. 1 mole equals this number right here. Okay, so just like saying a dozen equals 12, 1 mole equals this number, and that number is called Avogadro's number, which is the scientist that came up with this number. Not to be confused with avocado or something like that. This is Avogadro's number. And so Avogadro's number is 6.02 times 10 to the 23rd. We know that that can also be expressed in your calculator as 6.02 E23, or this number at the bottom. This is why we like scientific notation, is because you don't want to have to type in this huge number every time you are dealing with this. And again, a mole is an expression to describe an amount of something. So we are going to be using moles, which is abbreviated MOL. We're going to be using moles to convert different things and to convert between different units. So conversion factors, if that doesn't sound familiar to you, I'm just going to write down some common ones so you can see what a conversion factor is. You don't need to write these down. But a conversion factor is like saying that 1 minute equals 60 seconds, or 1 year equals 365 days, or 1 hour equals 60 minutes, or 1 week equals 7 days. Okay, so this right here, this is what we call conversion factors. And so these are things that you've probably heard of before. The conversion factors that we are going to use that I do want you to write down are the two on top. So 1 mole equals the element's mass in grams rounded to 2 decimal places. 1 mole also equals 6.02 E23 atoms. So I'm going to show you what that first one looks like here. The element's mass in grams rounded to 2 decimal places. So I zoomed in on a little section of the periodic table here. Let's look at, say, lithium. Oops. There we go. Okay. Lithium, if we want to know how much 1 mole of it weighs, we look at the atomic mass of that, and we round it to 2 decimal places. Okay, so 1 mole of lithium equals the mass rounded to 2 decimal places, which would be 6.94. And that's grams. If we wanted to look back at sodium, 1 mole of sodium rounded to 2 decimal places would be 22.99 grams. We could look at potassium. 1 mole of potassium is the mass of potassium rounded to 2 decimal places, which would be 39.10 grams. Okay, so to find the molar mass is what we call it, or convert moles to grams, you look at the molar mass or the atomic mass and you round it to 2 decimal places. Your other conversion factor is that 1 mole equals 6.02 E23 atoms. So if you are trying to convert from moles to atoms, that is the conversion factor you'd use. So these are the 2 conversion factors that you need to know. The first one is if you're trying to convert from moles to grams. Second one is from moles to atoms. So the steps in calculating or performing these conversions, first step you need to write down the given. Second step, you need to set up the conversion factor and match units diagonally. And the third step is then you multiply and divide it to solve. So an example with units that you are familiar with, 17 days equals how many hours? So first step is write down the given, 17 days. Second step, set up your conversion factor. So we're going to write it like this. Okay. Do this step every single time, even if you don't know where to go from here. Always write a multiplication sign and a line. And so our conversion factor, you need to match units diagonally. So you have days here, and so since days is on top, days needs to go on the bottom. And your conversion factor is how many, you're trying to go from days to hours. So how many hours in a day? Okay, you've got 1 day is 24 hours. So what happens is if you match your units diagonally, if whatever you have on top and on bottom cancels out. And so the unit that you are left with when you solve it is hours, and that's what it's asking for, how many hours. So to solve this, you multiply this stuff on the top, and then you divide it by what's on the bottom. So this is the same thing as 17 times 24 divided by 1, which equals 408 divided by 1. And so 408 divided by 1 is just 408. Now notice you started with 2 sig figs, and so you need to end with 2 sig figs. So we have 408, which is currently 3 sig figs. We want 2, so we will round this to 410. And then always put your unit. So the unit that we're left with here is hours. And that would be your final answer. Okay, so now doing an example using moles, grams, atoms, all of that new stuff. 0.450 moles of iron contains how many atoms? So first step is write down the given. So you've got 0.450, and you need to write your units. This is moles of iron, which is Fe. So always your first step, write down your given and set up the conversion factor. Now you need to match your units diagonally, so this unit, moles of iron, because that's on top, you need to write that on the bottom. Moles of Fe. And we are trying to go from moles to atoms, and so if you look back at what you wrote earlier, you do have a conversion factor of moles to atoms. And that conversion factor is 1 mole equals 6.02 E23 atoms of Fe. Okay, so again, like I said, if you have a unit that is written on top and on the bottom, it crosses out. You are left with atoms of Fe, which is what the question is asking, how many atoms. Okay, so again, you multiply the stuff on the top, divide it by the bottom. So you would take 0.450 times 6.02 E23 divided by 1, which would be the same number, and you should get 2.709 E23. And the unit there is atoms of Fe. Okay, so now let's double check before we call that our final answer. Let's double check our sig figs. We started with 3 sig figs, so we need to end with 3 sig figs. If we rounded that to 3 sig figs, it would be 2.71 E23 atoms. of Fe. And that there is your final answer. Another example is how many moles are in 1.20 times 10 to the 23rd atoms. And so that is what you are given. And so you always start by writing what you're given. We're going to use the E because it's a lot easier. So 1.20 E 23 atoms. So always write what you're given and then set up your conversion factor. And so in this case, we are given atoms, and so because that is on top, we need to put atoms on the bottom. And if you look back at your conversion factor, you have, if you're trying to convert atoms to moles, it's 1 mole is 6.02 E23 atoms. And so you take the top stuff, 1.20 E23, times 1, and then divide it by the 6.02 E23. And so if you type that into your calculator, you should get 0.199335548. Okay, but we need to look at how many sig figs we're allowed to have. You have 3 in your given number, and so your final answer can only have 3. And so we look back at our units. Atoms is on top and on the bottom, so it cancels out. Our final answer is in moles. And with 3 sig figs, that would be 0.199 moles. And that is our final answer. Another example, how many grams are in 0.700 moles of silver? And so this is our given, so you start by writing your given. 0.700 moles of silver, which is Ag. And even if you don't know where to go from here, you set up your conversion factor. And moles, because that's what you're given, because that's what's on top, moles of silver has to go on the bottom. And we are trying to get to grams of silver. And so if you look back at your conversion factors, you do have one that goes from moles to grams. So 1 mole of silver equals the molar mass of silver to 2 decimal places. So you find silver, and you look at that mass on the bottom, and you round it to 2 decimal places, and that is what goes on top. So to 2 decimal places, it is 107.87 grams. So again, you take your top numbers, you multiply your top numbers, you divide it by the bottom number. So 0.700 times 107.87, and then divided by 1 is that same number. This equals 75.509. Alright, so let's look at what our unit should be. Moles here and here on top and on bottom, that cancels out. Final answer is in grams of silver, which is what the question is asking. We start with 3 sig figs, so we need to end with 3 sig figs. So our final answer would be 75.5 grams of silver. This last example is asking how many atoms are in 26.5 grams of helium. So again, first thing you need to do is write down your given, 26.5 grams of helium. You need to set up your conversion factor. So because you have grams of helium on top, grams of helium needs to go down here. And if you look at your conversion factors, you probably will see that you don't have anything that goes from grams to atoms. However, you do have a conversion factor that goes from grams to moles. So 1 mole helium, look up the mass of helium to 2 decimal places, and that would be 4.00 grams. So 1 mole of helium is 4.00 grams of helium. If you look now and cross out your units, what's on top and on bottom cancel out. So right now, if you finish this problem, your answer would be in moles of helium. The question is asking for atoms, so you need to go one more step. Match your units diagonal, so what's on top has to go on bottom. Moles of helium. And if you look at your conversion factors, you do have a conversion factor that goes from moles to atoms. And that conversion factor is 1 mole is 6.02 E23 atoms. Okay, so now your moles will cancel out, your final answer will be in atoms, and that's what it's asking for. So you take your top numbers, multiply your top numbers, and then you divide it by your bottom numbers. And so I'm going to take 26.5 times 6.02 E23 divided by the bottom numbers, divided by 4 times 1, which is 4, divided by 4. My calculator just gave me 3.988 E24. So let's look back and make sure that we've got our units and sig figs. First question had 3 sig figs, or the given had 3 sig figs, so this needs to be 3 sig figs. So our final answer would be 3.99 E24, and the unit that we're left with is atoms of helium. And that's your final answer.